today we get to do a big review of factoring when the leading coefficient is more than 1. So, for our first problem, it's going to read 2x squared minus 5x plus 2. Now, there's a multitude of ways to do this. One way is simply the guess and check method. So you could put the two parentheses. You could notice that these two parentheses multiply to give you a positive and add to give you a negative. So that means they both have to be negative, negative, because this will multiply to give you a positive. And the only factors of this 2 in the back are 2 and 1. So we could actually put the 2 and 1 in the parentheses. And then we're going to need to figure out what the front parentheses is. So 2x squared also only has two factors, 2x and 1x. So either this is 2x and this is 1x, or this is 1x and this is 2x. So we're going to double distribute to figure out which one works. So let's go ahead and try this. So we're going to have 2x squared minus 2x, and then another minus 2x, and then plus 2. So that's 2x squared minus 4x plus 2. So that is not the right one. So we're going to check the other one. So I'm just going to erase the top. So if this was 1x, we would have 2x squared minus 1x minus 4x plus 2. And that is the one that works, 2x squared minus 5x plus 2. So with trial and error, this factored form would be 1x minus 2 and 2x minus 1. You could have that written as 2x minus 1 and then 1x minus 2. That's a lovely answer as well. These are the same exact answer. So that's the trial and error method. Now, I'm going to continue the same exact problem, but we worked on those area boxes, if you remember. So I'm going to draw a box. And 2x squared would be in one of the boxes. The 2 would be in the other box. And then these two boxes would add to give you the negative 5x. So if this is 2x squared, one of the dimensions would need to be 2x, and one of the dimensions would need to be 1x. It doesn't really matter. If this is 1x, this is also 1x. And if this is 2x, this is also 2x. Now, this thing that multiplies to give you 2, it has a dimension of 1 and 2. So we'll go ahead and just put the 1 times 2 and see if this works. So if this is 2, because of this, 2 times 1x is 2x. And if this is 1 because of this, 1 times 2x is 2x. Now, 2x and 2x don't add to give negative 5x. So the 2 and the 1 here need to be flipped. So this needs to be the 2, and this needs to be the 1. And also, this is a negative. So this needs to be a negative 2 and a negative 1. So if this is a negative 1, we have negative 1x. And if this is a negative 2, negative 2 times 2x is negative 4x. So now the negative 1x and the negative 4x add to give negative 5x. So this dimension is 2x minus 1, and this dimension is 1x minus 2. So the factored form is 2x minus 1 times 1x minus 2. So that's another option of a way to factor this with a leading coefficient. I'm going to show you the third option. The third option happens to be my favorite, but these other options are also fantastic. So the first thing you're always going to do is multiply the first number times the last number. And 2x squared times 2x times 2 is 4x squared. So I'm going to just make this diagram. You don't have to make it. I'm looking for two numbers that multiply to give 4x squared that add to give negative 5x. So now I'm just thinking of the factors of 4x squared. We have 1x and 4x, also 2x and 2x. If it's adding to give a negative, they would both need to be negative because it multiplies to give a positive. So this is the one that adds to give the negative 5x. So I'm going to put the 1x and the 4x right here. Now, it doesn't matter if you have a 4x negative here and a negative 1x here. These are interchangeable. It doesn't matter how you substitute it in, but we're going to now substitute that in for this 5x. So we're rewriting this equation, 2x squared minus 1x minus 4x, and then plus 2. So this right here just became this right here, substitution. And if you remember that box we just drew, we had these two numbers in the box. So when you have four terms, you can factor by grouping the first two and grouping the last two. So you cannot put a parentheses next to a negative. So I'm going to slash and dash this. I'm going to make it plus a negative because minus is the same thing as plus a negative, and then put parentheses. So what's the greatest common factor of this first parentheses? They both have an x in common, and then you are left with 2x minus 1. You're just dividing this x out of each term. And then we want to get this to also be 2x minus 1. So I'm noticing it has a 2 in common, but if I take a 2 out, I'm going to have negative 2x plus 1. And I want these two parentheses to be the same so I can factor them out. So instead of taking a positive 2 out, if I take a negative 2 out, then you're going to have negative 4x when you have the positive 2x, and then negative 2 times negative 1 is positive 2. So when you take a negative 2 out, now the thing that you have in the parentheses is the same. So you can factor this out as the greatest common factor, 2x minus 1, and you're left over with x minus 2 or plus negative 2. So this is that thing that's the greatest common factor, and this is the thing that's left over. So we've pulled out the greatest common factor and written what's left over. So this is the exact same answer we got when we did trial and error and when we made the box. So there's three completely different methods that you can choose from of which you'd like to do. I'm going to do some more of these, and I'm going to do this method first on the next one. This problem is 6x squared plus 1x minus 2. Go ahead and pick your favorite method that we just did and do that for this. I'm going to pick my favorite method, which is 6x squared times negative 2 is negative 12x squared. So I'm trying to figure out what two numbers multiply to give negative 12x squared, but add to give 1x. So I'm thinking of the factors of negative 12x squared. So if it's adding to give a 1x, that means the bigger factor is going to be positive. So we could have 12x times negative 1x. That does not add to give 1. We could have 6x times negative 2x. That does not add to give 1. It's 4x times negative 3x. Well, this is exciting because that adds to give 1. So 4x and 3x negative are the two that add to give 1. So we're going to substitute that in to write this out longer so we can factor by grouping. So we have 6x squared plus 4x plus negative 3x and then minus that 2. So this right here, just substituted in for that right there. I'm going to write it also the opposite way so that you can see that no matter which way we do this, it will work. So I'm just going to leave this equation right here, putting the 3x first. So we're going to group the first two. Remember to group the second two. I'm making sure this is plus a negative, not a minus. If you put a parentheses next to a minus, you would be distributing that minus throughout. So you always want to make it plus a negative before you put the parentheses in. The greatest common factor here is 2x, and we're left over with 3x plus 2. The greatest common factor here, if you take out a negative 1, you have 3x plus 2. So the parentheses is the same. 3x plus 2 is one of the factors. And then what's left is 2x minus 1. So this is factored form. I'm going to check it in just a minute, but I want to show you you can do it this way too. So if you group the first two and group the last two, that's a 6x squared. The greatest common factor here is 3x, and you're left over with 2x minus 1. The greatest common factor here is 2, and you're left over with 2x minus 1. So the 2x minus 1 is what's going to come out front, and then you're left over with this 3x plus 2. Look at that. It's the same exact thing. These are identical. Multiplication's commutative, so it doesn't matter which parentheses is first and which parentheses is second, as long as what's in the parentheses is the same. I'm going to just erase this bottom part, and I'm going to check this through that double distribution method just to make sure that it works. So 3x times 2x is 6x squared. 3x times negative 1 is negative 3x. 2 times 2x is 4x. And 2 times negative 1 is negative 2. So this does simplify to 6x squared plus 1x minus 2. Another way you can check that is to draw the box. So if you drew the box, you would have the 6x squared. One of the boxes would be 4x, another box would be negative 3x, and the last box would be negative 2. So this and this are from the initial problem. And then these two are from here. It doesn't matter which is which. What matters is that when you factor it out, you get this. So if you think about this being a 4x and this being a 6x squared, the greatest common factor here is 2x. So if this is 2x, this is also 2x. And then if this is a 6x squared and this is a negative 3x, the greatest common factor here is 3x. So this line and this line are both 3x. And then 3x times what gives you negative 3x? And that would be negative 1. So if this is negative 1, this is negative 1. And then negative 1 times what gives you negative 2? That would be 2. So if this is 2, this is 2. So check this out. This dimension is 2x minus 1. And this dimension is 3x plus 2. 3x plus 2, 2x minus 1. It's still the same thing. So all of these methods, including trial and error, will all yield to this factored form. Next problem we're going to do is 4x squared minus 31x plus 21. Now, you're more than welcome to try trial and error, but you do need to realize that this could be 1x times 4x, and it could also be 2x times 2x. So you've got multiple options in the front. And then 21 is either going to be 1 and 21 or 3 and 7. So you've got some options to try. Instead of doing that, I'm going to keep doing that long method where I multiply the first and the last. So 4x squared times 21 is 84x squared. So what two numbers multiply to give 84x squared that add to give negative 31x? Now, since it's adding to give a negative and multiplying to give a positive, negative is going to definitely be for sure. So you need to think of the factors of 84x. So right away, I know it's 4 and 21, so negative 4x and negative 21x. That doesn't add to give me 31. Going this way is just going to get the number smaller when you add. So we need to go backwards. So does 3 go into 84? 84 divided by 3, it does, because that's, and 28 And guess what? That's actually 31. So negative 3x and negative 28x is our solution. So that's what we're going to substitute in instead of that negative 31. So we're going to rewrite this whole problem. 4x squared minus 3x minus 28x plus 21. Now remember, before you start parenthesizing, this really needs to be plus a negative. So you're going to group the first two, group the second two, and take out your greatest common factor. So the greatest common factor of the first two is just an x. And you're left over with 4x minus 3. Now, I'm hoping this parentheses is 4x minus 3. That's how you know it's factorable. So what do you need to take out to get it to be 4x minus 3? So 4 times what is 28? And that's negative 7. That'd be negative 28x, and that would be positive 21. So that works. So the 4x minus 3 is what's going to come out front. And then the x minus 7 is what's going to be in the back. And then again, check it really fast. Why not check it? 4x squared minus 28x minus 3x plus 21. This is 31. Negative, we know we did it right. Also, let's look at the box drawing of this. So you have a 4x squared. You have this 21, and then remember these two boxes are these two numbers. So one of them is a negative 3x and one of them is a negative 28x. So I happen to group them the opposite way, no big deal. But the greatest common factor between 4x squared and 28x is 4x. Is a 4x. So if this is a 4x, this needs to be a 4x. And then 4x times what is negative 28x, and that would be negative 7. 4x times negative 7 is negative 28x. So if this is negative 7, this would also be negative 7. And to get positive 21, negative 7 times what is positive 21, and that would be negative 3. So this would be negative 3. And then negative 3 times what is negative 3x. So this would be a positive 1x. You could just put x, you don't have to have the 1. And then here we go. That's 4x minus 3, just like this. And this right here is x minus 7, just like this. So there's a multitude of ways to check yourself and know that you factored it properly. Doing is negative 4x squared minus 4x plus 15. Now, I'm noticing that there's two negatives, and I don't enjoy it when the leading coefficient is a negative. I don't know why. So I'm just going to take a negative 1 out. You don't have to do this. You can take it out later, or you don't even have to take it out. I'll show you a multitude of the correct same answers at the end. Okay, so I'm going to look at factoring this, multiplying the first times the last. 4x squared times 15 is 60x squared. So what two numbers multiply to give you negative 60x squared? Because that's a negative 15. And if you're losing that, I would slash and dash. And add to give you 4x. So think of negative 60x squared. So I'm thinking of negative 6x and 10x. And guess what? That works right away. So this is going to be negative 6x and 10x. Doesn't matter the order. We're going to whip that right there. So just keep that negative 1 out front. So 4x squared minus 6x plus 10x, we've just substituted this in for the 4x, and then we still have that plus negative 15. So we're going to group the first two and group the last two. The greatest common factor here, again, just keep that negative 1 coming down, is 2x. I'm just going to go like this. And then left over, we have 2x minus 3. And the greatest common factor here is 5. And left over 2x minus 3. So yay, we have the 2x minus 3. We have the 2x plus 5. And we also have the negative 1 out front. So this is a lovely solution. Put this negative 1 into either of these. So this could be negative 2x plus 3 times 2x plus 5. That's a solution. You could keep the 2x minus 3 and you could distribute the negative 1 back here. Negative 2x minus 5. That's another solution. So all of these are the same exact factored form. They're all identical, so it doesn't matter which form you have, they all mean the same thing. You could take this and take out a -1. When we're factoring farther in the next couple weeks, we're going to make sure that each of these are in the most reduced form anyways. So even though you have two parentheses, you might be able to take out a greatest common factor, and you'll need to do that. The next problem to conquer, 8 plus 17n plus 9n squared. Now, the first thing I'm noticing, I hope you're noticing too, is this is backwards. So let's just rewrite it in the proper order. 9n squared plus 17n plus 8. Okay, we're going to go ahead and factor that. I'm just going to keep doing the long method. You're going to do whatever method works for you, and we should get the same exact answer. So 9n squared times 8 is 72n squared. So what two numbers multiply to give you 72n that add to give 17? Well, 9 times 8 adds to give you 17. So this should be 9n and 8n. That adds to give 17, and it multiplies to give 72. What a fun problem. Okay, so 9n squared. I'm going to go ahead and put the 9n, and it's kind of nice to do that because this greatest common factor stands right out as 9. You could put the 8 here, it doesn't matter. And then you have the 8n, and then you have this plus 8 coming down. So this is substituted right there. Grouping the first two and grouping the last two, 9n is the greatest common factor, n plus 1 is left over, and taking the 8 out here with an n plus 1 left over. So the n plus 1 comes out as the common factor, and the 9n plus 8 is what is left in the second parentheses. And then you might as well just check your work really quick. 9n squared plus 8n plus 9n plus 8. That is 9n squared plus 17n plus 8, so it works. We can draw the box for this if you want. You don't have to draw the box, it's just an option, and if you don't want to factor the long way. I didn't draw the box on the last one, I don't know why. So the 9n squared would be here, the 8 would be here, and then the 9n and the 8n are in either box. It doesn't matter which one. So the greatest common factor here is 9n, and it doesn't matter where you go next. It's like a little puzzle. So if this is 9n, this is 9n. 9n times what gives 9n squared? That'd be 1n. So if this is 1n, this is 1n. 1n times what gives 8n? That'd be 8. So if this is 8, this is 8. And then 8 times what gives 8? That'd be 1. So if this is 1, this is 1. So that's where you get your 9n plus 8, right there. And this is where you get your 1n plus 1, which is right there. And you can put the 1 in front of the n, that's totally fine. Next problem we get to do, negative 16x squared plus 20x plus 16. Right away I'm noticing I can take a 4 out of every single thing. And if I take a -4 out, my leading coefficient isn't negative. It doesn't matter, but it's going to be easier to factor. So I'm going to take out a -4. So if I do that, -4 times what is 16x squared? That'd be 4x. -4 times what is 20? That'd be minus, I'm going to make it plus a -5x. And that's an x squared. Okay, all is well. And -4 times what is 16? And that would be a -4. So let's just make sure we've got negative 16x squared, positive 20x, and then positive 16. Okay, so we just need to factor this now. So 4x times -4 is negative 16x squared. What two numbers multiply to give negative 16x squared that add to give negative 5x? So just think about negative 16x squared's factors. The bigger number needs to be negative because it's adding to give you a negative. So we have negative 16 and 1, that doesn't work. Negative 8 and 2, that does not add to give you 5. Negative 4 and 4, that does not add to give you 5. 3 3 does not go into this, 2 already went into this, 5 does not go into it, 6 does not go into it, 7. So this is actually not factorable. There's no two numbers that multiply to give you negative 16 that add to give you negative 5. So that means this cannot be factored any farther. You're done. It's not factorable. Problem's very similar. Instead of a 16, we have a 6. I wonder if this one's factorable. All right, so again, we could take out a greatest common factor. This time, there is a 2 in common, and I'm just going to take out a negative 2 because I do not like my leading coefficient negative. So negative 2 taken out, this would be an 8x squared plus negative 10x. I'm going to make it plus negative. That would give us a 20. And then plus negative 3. All right, let's see if this is factorable. 8x squared times negative 3x is negative 24x squared. What two numbers multiply to give you negative 24x squared that add to give you negative 10x? So, negative 24x squared. We're thinking of factors. If it's adding to give a negative, the bigger one needs to be negative. So we've got negative 24 and 1. That doesn't work. We've got negative 12 and 2, and that works. So negative 12x and 2x. Again, it doesn't matter which order you write these. We're now just going to substitute that in. So we've got the negative 2 out front. 8x squared plus negative 12x plus 2x plus negative 3. So this was just substituted for the 10x from here. And then you're going to group the first two and the last two. We don't need to worry about a negative there. The greatest common factor of the first two is a 4x. I'm just going to keep bringing this negative 2 down so I don't lose it. So if you take out a 4, this is going to be 2x minus 3. And then the greatest common factor here, there isn't one. It is already 2x minus 3. So we're going to take out a 1 because we need a placeholder for this parentheses. So we still have the negative 2 out front. The 2x minus 3 is the common parentheses. And then what's left over is 4x plus 1. So we can go ahead and check to make sure this works. This is 8x squared plus 2x minus 12x minus 3. That's what we're trying to get with the negative 2 out front. So that's our negative 16x squared. Negative 10x times negative 2x is 20x. And negative 2 times negative 3 is plus 6. So that works great. The greatest common factor between the 4x squared and the 4x is just a 1x. So if this is 1x, this is 1x. 1x times what is 5x squared? And that'd be 5x. So if this is 5x, this is 5x. 5x times what is 15x? That'd be 3. If this is 3, this is 3. 3 times what is 12? 4. So if that's 4, this is 4. And then the last one works out. So our factored form for this equation is 1x plus 3 and 5x plus 4. So that initial problem, all the stuff in the box, was 5x squared plus 4x plus 15x plus 12. And if you did it the long way, grouping, you would just take the x out, leaving 5x plus 4. And then you would take the 3 out, leaving 5x plus 4. So you get 5x plus 4, which is what this is. And then you get the 1x plus 3, which is what that is. So that's just looking at it a different way backwards. You can see that. Okay, so you might see this on a standardized test in the near future. It reads, the area of a rectangle is 8x squared plus 8x plus 2. The length is 2x plus 1. What is the width? Now, the area of a rectangle is like this. So if we have 8x squared, and this is 2, and if we know one dimension is 2x plus 1, we're just trying to find the other dimension. So you can try this on your own and hit pause right now, but we're really just factoring this and knowing that one of the factors is 2x plus 1. So you could do the box method or you could do the long method. I'm going to look at this and take out a 2. So 4x squared plus 4x plus 1. So what two numbers multiply to give 4x squared that add to give 4x? And hopefully you can quickly know that that's 2x and 2x. So that's going to substitute right in there. So 4x squared plus 2x plus 2x plus 1. And then you're going to group the first 2 and group the last 2. So the greatest common factor here is 2x. And you're left over with 2x plus 1. And the greatest common factor here again is 1. There's nothing that you need to take out. So the 2x plus 1 is one of the factors. Don't forget the 2 that we took out earlier. And then you're left with this 2x plus 1. So this is actually something special. It's called a perfect square. And this is a perfect square number. It's 2x times 2x. And this is a perfect square number. 1 times 1. And if you think about how you check this, this is 4x squared, 2x times 2x, and then this is 2x times 1, and this is also 2x times 1, and then the last one is 1. So you see how there's twice this number times this number? So if the middle term is twice the 2x and the 1, you can quickly factor this into just the 2x plus 1 squared, with the 2 out front in this case. You could always do the long method. That's just if you see that it's a perfect square. And then over here, if you continue doing this, 2x times what is 8x squared? That's 4x. So that means this is 4x. So 4x times 1 is 4x. And then if this is 1, this is 1. And if this is 1, this is 2. So if this is 2, this is 2. And if we already know this is 2x, this is 4x. So the factored form for this is 2x plus 1 and then 4x plus 2. But this is what I was talking about earlier in that this is not factored all the way. You can take out a little bit more. So you can take out the greatest common factor of 2. So we still have the 2x plus 1, and then if you take out a 2, you have another 2x plus 1. And it's just easier to write this with the 2 out front. And then you can write the 2x plus 1 out, or you can just write 2x plus 1 squared. So regardless, that's the factored form for this fantastic story problem. The answer to the question, what is the width, is just 2x plus 1. And that's really tricky when you're taking those standardized tests, is you make sure to answer the question because I'm certain that that's going to be one of the answers. That's an option. You've done all this gorgeous work, but this is the answer to the question. Well, I hope you enjoyed learning and remembering how to factor things with a coefficient of something more than 1. And I'm sure I'll see you soon. Have a lovely day.